Hello civil engineers, welcome back to the lecture. So in this lecture, we'll try to see how to take out the quantities for the combined footing. Okay, that is a BBS for a combined footing. Now, one thing you need to understand in the combined footing, what will happen in the isolated footing, we used to have a bottom mesh. That is, this is bottom mesh on the longer span and we have a on the shorter span. This was the isolated footing, isn't it? But in case of combined footing, what will happen? Same thing. You will have a bar in the longer span. You'll have a bar in the shorter span also, but this is in the bottom reinforcement. In the same way, on the top also you'll be having a bar in the longer direction and you'll have a bar in the shorter direction. So that's the only change what you'll get in the combined footing, which you can appreciate here also. If I try to drag this particular image, so just observe here what has happened. So you can see the bar is in the bottom also, okay, longer span and shorter span. And similarly, the top also we are providing a reinforcement. Okay, very simple. So for this, I'll teach you how the BVS has to be done. So already I have prepared and kept it. First, I'll explain you. Then we can try to prepare the same Excel sheet. Okay. Yeah. So in our drawing, we had a footing that is F6, which was a C plan they had written. C plan means it's a combined footing. They did not mention it here. And also you remember, whenever you check the drawing, no one will mention you that isolated footing, combined footing and all. The moment you see if any footing has a top reinforcement, most of the time it will be your combined footing. Okay, like this is shorter, that is bottom reinforcement, whereas only for this footing, that is F6 footing, they have given the top reinforcement. So usually the meaning is that it is a combined footing. Now another case is that it's not that all the time whenever you have a top reinforcement, it will be a combined footing. No, that is not the case. There are every chance even isolated footing will have a bottom and the top reinforcement. So remember my words, there's every chance you have a isolated footing, but you will get the reinforcement even in the bottom and also on the top. Usually this happens in case of industrial structures and all, where I had given you the assignment for the plinth beam and all. No, so those are industrial structure. There, even though it is a isolated footing, you get the reinforcement in the bottom and also in the top. The reason is that the load coming on the footing is more, and it is subjected to wind pressure and all. Because of that case, what we do, we try to provide top reinforcement also. But don't be under the impression that wherever the top reinforcement will come, only that is combined footing. No, that is not the case. Okay, fine, this much is understood. Now we'll go forward. So in this, what will happen, we have written like F6 footing, and just see the size of the footing. It is I see the size is not given here. In that case, you have to come to the AutoCAD, and once you come to the AutoCAD, yeah, this is my footing. Okay, yeah, so this is my F6 footing. You can see this is F6 footing, and I've given the size here. I mean, I've taken a dimension. Outer to outer it is 3000 mm, and from here to here also it is 3000. That means the size is 3000 by 3000. Great. So that is the same thing I've written. Size is 3000 by 3000. Coming to the depth of the footing. Okay, yeah, coming to the depth of the footing, the depth is given here. The depth won't be shown here. You have to come here in the C plan. What is the depth? F6 footing, it is 500. So I'll input 500 here. So I've written 500. Where is that? Yeah, I think I didn't upload. Yeah. So this should be 500. Okay, write 500. Done. Great. So the same thing I've done here. Length is 3000, breadth is 3000, and depth is 500. So first we'll start with the bottom bar. Here I didn't write bottom bar, top bar, because it is understood it is an isolated footing. Only the bottom reinforcement will come. But here I'm writing, first I'll do the bottom bar, then I'll go with the top bar. And you see the shape of the top bar, it is something like this. Bottom bar, it is like this. Okay, I'll teach you all these things, how it has to be done. Now coming to the bottom bar, again, same shape you have to draw. Okay, nothing is changed. The method remains the same. You'll write here F6 bar along the shorter span, F6 bar along the longer span. How many footings are there? This isolated, this combined footing of F6, how many are there? So if you go back to the drawing, it is written only one. So only one number. Even in the plan, you can see this is only one number here. Only one footing we have. So I written one here. Okay. Now come to the diameter of the bar. This also you need to input. No, go back to the drawing. Come to the F6 footing. So observe this part. What it says. So it says that you're supposed to make use of a 10 diameter bar at 150 center to center spacing in the longer direction in the bottom. Similarly, 10 diameter at 150 center to center in the bottom in the shorter span. Even in the top reinforcement, you're supposed to provide 10 diameter at 150, 10 diameter at 150. So your calculation will be very simple now. So what you do, come here, go back to the Excel sheet. Input 10 diameter at 150. Here also you input 10 diameter at 150. Now coming to the number of bar. How do you find number of bar? I want to find the number of bar in the shorter span. So what I'll do, I'll take the longer span, that is 3000 minus 50 divide by spacing of the shorter span, which is 150 plus 1. So same thing I've done it here. See, where is that? Yeah, what I've done, round up. Always remember in Excel sheet you have to write round up. 3000 minus 50 divide by spacing, that is 150 here, plus 1 comma 0. So if you do this, you'll get 21 number of bar. Okay, now coming to the cutting length. So cutting length, what you do, see, yeah, cutting length, what you do, cutting length will be, how do you find? Very simple, 2900 plus 267 plus 267 minus 4 times the d, because I have 190-degree bend here, another 90-degree bend here. Okay, so 2900 plus 267 plus 267 minus 4 into diameter of the bar, which was 10. Okay, so you'll get 3393 mm. So this is in mm. I'll convert this into meter, divided by 1000. Got it? Now we'll find the total cutting length. So total cutting length will be cutting length of one bar, which was 3.393. I'll multiply this by number of bar, which is 21. Multiply this by number of member, that is number of F6 footing, which is only 1. So if you multiply this, this and this and this, you get 71.260 meter. Now we'll find the weight of the bar. This is in running meter, no? We have to find the weight of the bar. So weight of the bar, it's a 10 diameter bar. And for 10 diameter bar, the weight is 0.617 kg per meter. So what I'll do, 71.260, I'll multiply by 0.617, which will give me 43.967 kg of a steel is required. So my shorter span is done. Now come to the longer span. Again, I've written F6 bar along the longer span, one number. Again, of course, if you see the drawing, your shorter and longer, both are 10 at 150, 10 at 150. So that is why I've written again 10 at 150. How many number of bar? Obviously, this also will come 21, because your length and breadth both are same. Your spacing is also same. That is why 21 has come. Still, you have to write equal to sign, round up. Now, you want to find the bar in the longer span. See, always remember this method. Even though the dimensions are same, it's okay. You apply the logic. I want to find the number of bar in the longer span. So what I'll do, I'll take a shorter span. So shorter span is 3000. So 3000 minus 50 divide by spacing of longer span, which is actually 150 plus 1. I have to do comma and 0. If I do, it will take the next higher value, which will come 21. So cutting length will be how? It's very simple. So cutting length will be again 2900 plus 267 plus 267, which will and minus the bend deduction, minus 4 into d. Okay, 3393. So this will be in meter. So again, this total cutting length will be again same. 3.393 multiply by 21 multiply by 1 will give me the total cutting length. Again, weight will be same, because 71.260 is a cutting length of the bar of this F6 footing. And what is the weight of a 10 diameter bar? Because we are using a 10, so it comes out to be 0.617. Got it? So in this way, I have explained you for the bottom bar, and whatever we did for isolated, same thing is here. Now the question is about the top bar. How do you do the top bar? Nothing. It's very simple. If you observe the drawing here, this practical, you will get an idea. Wherever your bottom reinforcement has gone, you have to tell me few things. Wherever your bottom reinforcement longer span has gone, isn't that even in the top also the length is also same? Agree with me? Obviously, top also whatever L you are given, bottom also same thing will go, right? That means one conclusion you can draw. Whatever my bottom longer span length I got, same thing I need to write in the top. Got it? Second thing, whatever is your shorter span, whatever is your bottom shorter span length, that is L and whatever length you got, isn't that the same? Even on the top also you have done the same thing. Top also it is same thing. That means nothing will change. Only the shape of the bar is changing. In bottom, when I'm giving a shape, my shape will be like this. This will go to the top. And when I'm giving at the top, my shape will be in this way. Right? Agree with me? Same thing practically you can see also. Right? That's the only changes. That is the only change you're supposed to do. Right? So that is why in the Excel sheet what I've done, I've written top bar now. How do you do this? Again, you know how to do this. It's pretty simple. Okay. What I've done is I had just copied the same thing from here. I copied it here. I did Control C, okay, and I pasted it here, okay. I pasted it here and told it is F6 footing, and all those changes I had done, okay. And then what I did, no, then I inserted 2 rows here. here. Here I inserted. Click your mouse here, keep your mouse here and say control and plus. So the moment you do control and plus, two rows will be inserted and you can merge it in this way. Select, say merge at center. Now you write here bottom reinforcement. See, all these things you should do. Okay. Bottom reinforcement. Done. If you want to change the color to differentiate, I'll give a red color, not red. I'll give a blue color. Yeah. So bottom reinforcement will be done. Now for the top reinforcement, what you do? For the top reinforcement, you just select this. Select it in this way. Come here, give a white color. Okay. You give a white color. Now this much area you can utilize. Now again, what you'll do? You can make use of this border option. Draw border. Now you draw the border like this. See one. Okay. Come here. Yeah. Draw border. 2 and 3. So this is top reinforcement, your shorter span you did, and then leave 2 3 space and come here. This is your another one. Finish. Done. You got the shape. Else you can use you make use of this insert button, illustration shape, and this the normal method what I thought, and that also you can do. Okay. It's totally up to you to follow whichever you want. Instead of doing this shape method, follow this border method. It's easy actually. Okay. Done. So this is done. Next, what you're supposed to do, you write here, you just select this portion, merge at center, and right here it is top bar. Now it's understood. So then you can decorate it, bring it the center, and then you take this, make it bold, and color we have given blue, and if you want, increase the font. Finish. Bottom reinforcement, or you can write top reinforcement. Okay, done. Finish. So next, what you're supposed to just copy this, whatever you have written from here. No, you say Control C and bring it somewhere here. Okay, bring it center here. Else you can do one more thing. You can even arrange this properly. Why? You just merge these two cell. This two will be one. Okay. First you do that, merge it in this way so that this will come in the same line. You're getting my point, no? Because it should look good. That is why I'm doing all these things. Otherwise, it's not actually required. It's not actually required. Because if tomorrow somebody asks you Excel sheet, it should be in a readable format. Even he should find it good while reading. Done. So this one are done. You can erase. If an extra comes, you say no border, it will go. And then you select and then say thick border. Okay, done. This is also not required. Come here, or even you can say erase border, and now you can erase it in this way. Okay. Okay, don't, yeah, erase. Now what you do? Now you copy this. Say Control C, bring it here and say Control V. Okay, it cannot be done. No problem. Then you write it. Then you say Control C, paste it here, Control V. Okay, and now you increase all these things. It will take some time. If you can copy, you can copy. Sometimes that will not happen, not an issue. So what is the footing name? It is actually F6 footing, not F9. Okay, so write F6, write F6 footing. Okay, this also F6. Okay, done. Now come to the number of member. It is 1, no? I'll input 1 here. So first let me do that. Select, take it to the top, middle, increase the font of that, and then do this also. So that you don't have to change every time. Okay. What is the dia of your top bar? So dia is also again 10 diameter at 150, longer direction. B2 means shorter direction in the top. Okay. 10 at 150. So what you do? 10 at 150. So dia is again 10 and spacing is again 150. Okay. Done. Next, what we'll do? We'll find the number of bar. Now to find the number of bar, we have to input this, no? So what will be this portion? You are doing a shorter span for a shorter span. So plus, open the bracket. Okay. So what you do first? Okay. We need to change few things. No, I didn't do that. Anyhow, we'll do it quickly. So this is actually 3000. This is also 3000. This was 500, isn't it? Yeah. This also I'll change. This was 3000. This was also 3000. And this was 500. Okay. Got it? No, you also try to do along with me. Don't wait. Yeah, now this will come. So you can round it up. Plus, we'll write round up. Okay. Why this is coming? Because again, we should round it up. Okay. This will write comma 0 and close the bracket. It's not coming, so you have to open the bracket again. Open the bracket, close the bracket, enter. Now it's okay. You got now why this is coming? Because the decimal point will come. Whenever the decimal point comes, you should say round up. Or how many open brackets you get, no, that much close bracket you should do. Sometimes see, now if I don't give this bracket, it will show error. See, this error will come. Whenever you get an error, something like this, it means that the number of open bracket and close brackets are not matching. So now you see how many open brackets are there? 1, 2 open bracket is there. And here another 3 open bracket. So 1 close bracket, 2 close bracket and 3 close bracket, and hit enter. Now it is all right. Okay. So if you get such problem, that means your open bracket and close bracket are not matching. Try to see. If you open 3, then close 3. Okay. Great. Fine. So once this is done, yeah. This answer we have verified. Now you see this is matching, no? How much we got here? 7126. This is also 74 we are getting here. Okay, I'll verify it. Okay, so that okay, this is 150, no spacing. Now it should be all right. Yeah, now it is all right. See, 71 to 74, 71, 260, 260. Here small changes will happen. It's okay, no issues. We'll go with this only. Yeah, 10 at 150. Now you infill this. I mean, yeah, plus open bracket. So shorter span, no? Shorter span is how much? 3000 minus 50 minus 50. Close the bracket. Okay, 2900. So bring it at the center, make it bold if you want, change the color to the red, and this also you change it. Got it how it has to be done? Finish. Now here you don't input again. I mean, you don't have to write again. Simply interlink it. That means plus, just click on this. Click on this part. Okay. And hit enter. I mean, click here, plus this portion, enter, finish. Same thing it will copy. Again, here also plus, you can copy this or you can interlink this. Anything is okay. Interlink this. And then this has gone to the side. Click on this and bring on the left side. Okay. This also correct. So click both, make it red in color, make it bold and change it. Finish. Looks good, no? Now everything is correct. Now number of bar. How do you find the number of bar? So for number of bar, again, we have to do round up. Okay. Open the bracket. Then 2 times you have to open the bracket. So we are finding along the shorter span. If you're finding along the shorter span, I need to take the longer span. So longer span is 3000 minus 50 on the left side, minus 50 on the right side. Close the bracket, divide by spacing. What is the spacing? 150. Now it's not visible. I'll directly write 150. Okay. So this 150 when you write, again you have to write this. You have to open the bracket. Okay. And close the bracket. Finish. Then you write plus 1, comma 0, bracket close 2 times and enter. Okay, again that error is coming. The error is again for the very same reason. 3 open brackets and this close bracket is not matching. Put yeah, now it should. Because why this error came? No, I gave 2 open brackets this time. So what happened? 1, 2 and 3 open brackets are there, but closing bracket you see 1, 2, 4 brackets. So again it didn't match. That is why I got this error. So in that case, what you do? You deduct one thing. Okay. That's it. Now it will be all right. See, 21 number of bar I got. Here also I got 21. Correct, no? Fine. Now find the cutting length. So cutting length, you know, plus what you do? 2900 plus exactly 267 plus 267. Then what you do? Minus, open the bracket, 4 into D. 4 into multiply by D. D is how much? 10 diameter bar. Close the bracket. How much you're getting? 3394, 3394. Again, this answer is cutting length in meter. So what you do? This answer you divide it by 1000. So you can put bracket and you can do that also. It will be correct. Okay. After that, now come to the total cutting length. So total cutting length will be how much? Cutting length in meter multiply by number of bar multiply by how much? number of member. That's it. We'll get 71.274, 71.274. Same thing. Why? Because this and this will obviously match. Okay. Here also you see, I got the same thing. 71.260. That small aeration is okay. Fine. Now come to the weight of the bar. Weight of the bar, we are using a 10 diameter. No, come here. Plus 71.26 into 10 diameter bar is 0.617 and enter. Finish. How much we got? 43. You can keep it to 2 decimal. Yeah, okay. 2 decimal, it will come 44.00. Here we got 43.96 here, which is close to 44 only. Okay, done. Finish now. So the top one you have finished. If you want, you put dash here. All these things you can put dash. 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 Now come to this portion. Again, this portion what you will do. So this is shorter. Now this is your longer one. So again, do the same thing. Longer also will be plus, open the bracket. So for the longer, what is the size you have? Longer is 3000 minus 50 minus 50. Close the bracket. Now you may ask, sir, whether we can interlink this. Instead of writing, can we interlink? You can interlink. But don't follow that method. The reason is that here length and breadth both are same. So if you interlink, nothing will change. Tomorrow you may get a footing where length is 3000 and breadth is 2500. In that case, you have to do it separately. That is why I'm teaching you separately. Okay, fine. So again, bring it the center. And now this you can interlink because this anyhow will not change. This you can interlink, not an issue. Okay, fine. Done. No? Click on both of this. I mean, click on this, bring on the left, make it red color, change this font. You can make it bold also. Click on this, make it bold and red in color. Okay, done. No? Finish. Now this looks good. Now these things again you need to copy. Try to copy. Say Control C, and before that, you just merge it. Otherwise, it will not look good. So these three you merge together in this way. Okay, once you merge, say merge at center, and then thick box, and yeah, box will come. Okay, now again select this, say Control C, put here Control V. Yeah, now it will come, no problem. Okay, so only the thing is shorter, you change this one to as longer span, because now I'm finding the longer span direction. Okay, I hope you are able to understand these things. Rest things anyhow you're interlink, but make sure it is correct, because since you're interlink, okay, anyhow we'll make it correctly. Longer span 1 bar, 10 diameter 150. So number of bar you change it. Number of bar, what we'll do, we are finding the longer span, so I need to take the shorter span. The shorter span is 3000 here, and hit the enter. Yeah, so 21 I got. Cutting length is same. This is correct. This is also correct. Here what will happen, this will change into 0.617 because it's a 10 diameter bar. Hit the enter. Got it? No, both are 44 and 44. Correct. And here also you see everything 43, 43.967 we got. Even if you want, you can make it as 44 also. If you decrease this, no, yeah, it will become 44 here. Not an issue. Okay. See, here also we got it. No, how it has to be done. Now what you can do, you just can yeah, just select this and make this as, give one thick box. Fine here. So done. And then you can merge this thing. So select this and say merge at center. Now this will look good. So here you can give a border now to make it look good. Select that, this border you give, so it will look good. And this also you select like this and say one border. Now it looks good. Got it? No. So this is your combined footing. If you want, mention combined footing here if you want, else not required. Okay, everything is correct. Yes, fine. So bottom reinforcement is done, top reinforcement is done. Okay, great. So I hope you have enjoyed the lecture up to here. You're able to understand how the combined footing reinforcement has to be done. Okay, so try to prepare the Excel sheet. It's very simple preparing the Excel sheet. And once you interlink and all, just try to verify your answers. Okay. Yeah. Because why I'm telling is in this drawing, whatever we have there, it was easy for our calculation because 10 at 150, 10 at 150, everywhere it is 10 at 150. Now in some other drawing, you may get where your bottom reinforcement is 10 at 150, 10 at 150. Top is, let us say, 10 at 200. So in that case, what we do, we write 200 here, write 200 here. Accordingly, your answer should change. So did it change? It didn't change, isn't it? Because spacing, yeah, it didn't change because we had not interlinked. So in that case, this 150 will become 200. Okay, 200, and this will become also 200. Okay, I'll tell you how it has to be interlinked. I'll interlink because last time I didn't get chance that because it was not showing. Now we'll interlink this. Okay, see. Okay, what happened? Yeah, correct. And now here also I'll interlink. Okay, so when I interlink, no, so this will change automatically. See, your answer also got changed. No, now let us say instead of 200, your spacing was 250. Now you see everything will change. 13, this also is 250. Finish, got it? So that is why you have to interlink. Now instead of 10 diameter, let us say in AutoCAD, instead of 10 diameter, it is 12 diameter. I'll change everything here. Let us say you are working on a project where you got this as 12. Instead of 10, it is 12. And this spacing, I'll go with the 225. Okay, 225. One thing. And here also it is 12 only. Usually that changes will not happen. The structure consultant will not make it so much, so much changes will not happen. But still for our calculation I'm doing. And I'll say this we are going to place it 250. Okay, usually that doesn't happen. Okay, as far as possible, the structure consultant will try to give 150, 150. Top also will keep it 150 only. Even though 225 is a requirement, we go with same so that execution point of view, it will not be a problem. That is why most of the structural drawing it will remain same, but in few places and all due to some condition we try to change. It's okay. Okay, so this is L2 is longer. Okay, and B2 is shorter span. Okay, okay, shorter it is 250, longer it is 225. What you do, shorter, no, so shorter you make it as 225, and longer it is how much? 2. Okay, shorter it is 250, no, B2 it is 250, 250, and this is 225. Okay, how did I identify? I written shorter here, so this is shorter. B2 means shorter span, and L2 is longer span, 225. So longer I've written 225. And diameter, what I've done, both are 12, 12. So what we'll do, here also 12. Okay, and here also 12. Done. Now you see everything got changed, isn't it? That is why you have to interlink in the Excel sheet. Everything will change. Simple. So if you get a problem, something like this, it will change. In the same way, I'll change the dimensions also. Instead of this dimension, I mean, now I'll not change, I'll show here only. Instead of this 300 by 300, let us say you have a footing which is 4500, and this is 2500. So automatically everything also will change here. You see, everything got changed, isn't it? That is why you have to interlink everything so that it is easy for you to do the calculation. Great. So I hope you have enjoyed my lecture up to here, and I've explained you everything regarding the combined footing, how the BBS has to be done. I've given you different case studies also, how it should be done. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So I hope up to here you have finished your Excel sheets and we have understood everything. The combined footing is also covered, and also I have covered the isolated footing, and this entire drawing, whatever was given, all the BBS we have done. Okay. So once that is done, the final thing what we are supposed to do is a total quantity that is required. Now what we have done for each footing, we have found that this much steel is required, right? 10.90, 11.16. But when you give the final details, okay, it should be something like this. You should come within a single glance, you should come to a conclusion like 8 mm how much bar is required, 10 mm how much is required, 12, 16, 20, 25, and 32. And out of that, what is the total steel that is required? So for that, what I've done, I've prepared a kind of row here. So in this way, we can identify. I'll teach you how it has to be done. It's very simple. So what you can do is, I'll do it here. Okay. Since we did up to there, I'll do it here. Or I can do it here also. Anyhow, I'll do it here only. Okay, what you do, you just select. So once you're finished up to here, just select up to this much amount. Okay, and go here, say merge at center. Okay. And then this part, what you do, you have to write all these things. Okay. So what you do, again, whatever you have written, same thing you copy, like 8, 10, 12, 16, 20, 25, 32, Control C, and you paste it here. Okay. So it will come in the same line. It should come in the same line. Once that is done, next what you're supposed to do, you drag this one. 3, 3 you can take, or 3 or 4. It depends on you. Okay. So this will put under one column or one row and give a border to that. And next, this part also you put. Okay. Yeah, this will be for that. And this part you write up to here, this much. This will be for one, and this will be for second. You're getting my point? And then say merge at center and give a thick box. Done. Everything you're done. And here also you give a, make it bold, thick box. Okay. Now this entire thing you select, go here, keep it in this way. If you want, increase the size of that. Okay, great. Everything is done. No. Now we'll write that. That is total steel required for which one? It's a G+2 building. What we did, G+2 building, or you can write residential building. Okay. Okay, footing. And you have to write always, actually when you write the final thing, it should be in metric ton, but I'm writing both kg and metric ton. MT is metric ton. Okay. So this is how it is. Once it is written, bring it to the center, and then you increase the size of that. And if you want to change the color, change the color. Okay. And write total steel. Fine. Total steel. Got it? Done. Now 8, 10, 12, you just have to come and check here. Okay. Whether everywhere in this particular footing, luckily all the diameter what we are used, it is 10 and 10, 10 and 10, 10 and 10. Everywhere it is 10, 10, right? So everywhere it is a 10 diameter bar what we are used. That means the weight also has come in the 10 diameter column. All right. So what you do, you come here. 8 anyhow, you can make it 0. Okay. 12 also it is 0. Since there is no steel in that, everything you make it 0 except the 10 diameter. Now for the 10 diameter, what we'll do, we'll select plus sum and open the bracket, and then go on selecting from here. Okay, we'll start from here. This is 10, no? So drag it in this way. Okay, so in this way you drag it so that all the values should be selected under the 10 diameter bar. Okay, up to here. So and then close the bracket, hit the enter button. So done. So what happened this time? It's coming 966. Okay, let me check it once again. It should not come. It should come properly. Sum, open the bracket. We'll start from here. Straight you go to the top. Okay, up to here, no? And then close the bracket. Enter. Okay, it's coming 966. That means here there might be a mistake. Otherwise, we'll do one thing. Okay, no problem. We'll individually will pick it up. Okay, sum, open bracket, you are done, no? We'll start from the top. Okay, individually pick it, not an issue. Like this one plus this one. Okay, this one plus this one. Then plus this one plus this one. How much is 6 is done? 1, 2, 3, 4, 5, 6. Yeah, 6 are done. Plus 7, 8. Plus this one plus this one. 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 Plus this one plus this one, right? Everything is selected. Close the bracket, hit the enter button. So it's coming 841.448. Then it is coming 966. No, it's coming 966 here because it has chosen everything. But anyhow, not an issue. We'll follow the same method. Okay. Sometime in Excel, some changes will happen. Not an issue. We'll pick it individually. Okay. Yeah. Plus sum. So we'll start from here now. This one plus this one plus this one plus this one. Okay. Plus this one plus this one. Okay. 1, 2, 3, 4, 5, 6 values are done. Yeah, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah, 6 values are done. Plus this one, 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 and plus this one. Done. Everything is done. Close the bracket, hit the enter. Still it's coming 966. And here it is coming 841. So we'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's coming here. And here 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is correct. And here it's coming 1, 2, 3, right? See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That means 3 are missing here, right? No problem. We'll verify that. Okay. Because again, I told you, whenever you miss anything, you should know to verify that also. I think this is missing. We have not considered this particular thing. N144, you see, N144 is missing, no? Now it is correct. Plus, again, go to the top. See, even this is also missing. N130, that is also missing. So 2 we added, and I think one more is missing. That also we need to add. Yeah, see, even this is also missing. Yeah, now it is okay. And close the bracket. N100 was not added. Now hit the enter button. Yeah, see, now it's correct. Right, got it? 966.236, 966. Again, we were successful in identifying the error. So this is how we are supposed to identify the error. Okay, great. Chalo. Yeah, done. So other than that, 12, 16, 20, we don't have, no steel is coming. Just in case here, if it was 12 diameter bar, then under the 12 diameter bar, we would have written that. I'll show you that later also. Okay, done. So once that is done, next nothing, you have to add it. Okay, here we'll write everything in kg. That is this plus this plus this plus this plus this plus this. Okay, so again, it is 966 only. So this is the total steel that is required everywhere, including all the steel. Here it is showing only 10 diameter steel, how much it is required. Here it is showing the entire steel that is required. And here what we'll do, this answer will divide by 1000 so that your answer will come in metric ton. So 0.966. So this is the actual steel that is required in metric ton. Usually when you order the steel, no, you order in metric ton. You don't order in kg. Okay. So you should say this much metric ton of steel is required. So that is why I've written metric ton. MT is metric ton. Kg, normal speaking, when I say metric ton, you don't understand the quantity. But when I say in kg, you get an idea. Okay, 966 kg. Okay, done. Similarly, here we had written total rebar quantity. I've interlinked this. What I've done, I'll do it once again. What I did is here plus I have interlinked that with this value. Okay, with this value interlink in metric ton. Enter. Finish. Okay, tomorrow if I just change this value instead of this, now I'll show you what will happen. Now let us consider, I'm giving some random values. I'm getting a 12 diameter bar. Let us say, okay, this is the final answer. You also should get the final answer, something like this. Even if it is very close to 950 also, it's okay, doesn't matter. Okay, okay, so try to do your Excel sheets and you should get 966.236. Even if you get 975, even if you get 960 also, it's okay. You don't have to be you don't have to get exactly same. Here, if your value lies in between, if your values lie in between 950 to 1000 also, it's okay, not an issue. Okay, you don't have to worry. Maybe somewhere you might have made mistake and it's okay, totally okay, not an issue. Because again, we add 5% wasted to this. Okay, chalo. Now let us consider in this footing, somewhere we had a 12 diameter bar where it was 230 kg steel had come, and 8 and 20 diameter we had got some 450 kg steel. Finish. See, automatically you see the Excel got updated, isn't it? So 966 plus 230 plus 450 will give me 1646. and 1646 divided by 1000 is 1.646 ton, and automatically you see 1.646 has come here. So that is how the interlinking should be done, so that you can do everything in a better way. Okay, fine. Okay, that's it. Now again, this is the final thing what we have got. Usually when we do this thing, uh, estimation sheet in this way, we usually add a 5% wastage to this. Okay, even though you're getting 966, you can add 5% wastage to that. Okay, either you can add, you can make a separate column, you can make a separate row here and say 5% wastage, or here itself you can add it. Okay, if you want, I'll do it here only. I'll add one more this thing, and here what I'll do, this is for the wastage. So when I say wastage, you say 5%, no? So 1.05 1.05, why it is? Because 5% is, it's 1.05. If I multiply by this is my wastage. Including the wastage, this much still you need to order, because whenever you order the sheet, it's not that the same quantity will go in the execution. 5% may go in wastage. After that, that is why we try to keep those, we try to prepare the reconciliation sheets and all later. Okay, anyhow, so this is one way of doing. If you don't want to do in that way, write 0.05 multiply by this plus 0 point. If you do, okay, this is okay, you follow this, plus 1.05 into 0.05 is 5%. Okay, if you don't want to do it in that way, there is one more method which you know what you do. That's simple. You write this 966 plus open bracket 5%, no, 0.05 multiply by this value again and close the bracket. Same answer you should get. Yeah, see, 1014 only you got. You can follow both. This is easy. 1.05 into this answer will give you 5%. This value, whatever you got, it is after the 5% of wastage. Okay, that's a common practice. What we do, we add 5% wastage to the steel what we have got. Okay, so I hope you have enjoyed my lecture up to here. Try to prepare the Excel sheet and try to get an answer somewhere close to this. Okay, I've given you a buffer zone from 950 to 1000. If you get it's okay. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So in this lecture, let me clear few of your doubts. So whatever I taught you so far in the footing BBS, you may have few doubts like when we should consider the bend deduction, when we should not consider the bend deduction. Then in few of the cases, I told you this depth, whatever you are supposed to take, you have to take 2/3 of the depth, right? Here, if you remember, we are taken 2/3. In some of the cases, I told if it is not required, not to be taken. Now, when do you use such cases? I'll give you complete information here. See, whatever I told you right now, everything depends on the, I'll write it here. Okay. Yeah. So whatever I told you, everything depends on the type of project that you're working for. Okay. We'll make it. Yeah. So TY, type of project. Okay. That's the first thing. Second thing, it depends on the client. Second thing, it depends on the client. Okay. Client and let us say contractor. Okay. Client and contractor. So client and contractor. So again, it depends on the way you, for which company you're working, which company you are working, and what they follow Okay, these are the three things which depends on that. Now I'll give you one by one cases. So let us say you're working in one company. Let us say this is company number 1. Okay, and what they follow is they follow the bend deduction. They say we have to consider the bend deduction plus whatever this L you're taking, you have to take it completely. Okay, second plus L completely. I'll write L completely. Got it? So this is the first thing. So in that case, what you do, what is the reason? First is you have to consider the bend detection, and the L, whatever you're taking, you have to take it completely. So this is what that particular company follows. So if that is the case, nothing. Come to Excel sheet. Okay. Bend deduction, anyhow, I applied the bend deduction. Here you can see the bend deduction minus 4 times I have applied it. This depth, whatever you have taken, no, they are telling to take it complete depth. That means instead of multiplying this by 2/3, that means whatever answer you are getting, that is overall depth minus top cover minus bottom cover, and whatever answer we got, we used to say 2/3 of that, because that is a general construction practice what we do. Now in your company, if they say you don't have to take like that. You take complete height minus the top cover minus the bottom cover. This is what we are following. Then you're supposed to follow that. In that case, you just remove this 2/3 from there. Finish. Automatically your answer will be 300, 300, and automatically you see this also has changed. So in the Excel sheet, you see here, initially it was 8.11, the weight of the steel, and cutting length was 13.14. The moment I change that, okay, just remove that. Finish. It came to 9.22 and it came to 14.940. Got it? This is case number 1. If your company is following this, or if your manager has told you that this is what we are following in a company, then you follow this. No harm in that. Okay, first thing. Now we'll go to the case number 2. So again, coming to the case number 2. So the case number 2 is, let us say, in your company, they told no need of bend deduction, no need of bend deduction. Okay, you don't have to apply the bend deduction. Okay, and also you can, whatever L you're taking, you can take 2/3 of the L. That means whatever L we got, for that again you take 2/3. 2/3 means 67%. 2/3 L. I'll write in this way. Okay, 2/3 L. Right? This is another company. Let us say this is another company where you are working, or maybe that particular company is following this particular method or this particular bar bending schedule. No problem. Then what you do? You follow the same thing. Come here. What we are supposed to do? We are supposed to not apply the bend deduction, and we can take the depth up to 2/3. So in that case, simple, come here. So wherever you have applied the bend deduction, that is -4 into, you delete this part. Bend deduction is not required. So criteria number 1 is satisfied, right? Is satisfied. Finish. Second, this thing you say you apply 2/3 the depth. So 2/3. Okay. 2/3 if you do, it will be 200. Accordingly, you see your cutting length will be this time 13.5 and 8.33, 8.33. Previously, if it was something 9, so hardly there is any difference now. So we have taken two cases. One case where the bend deduction has to be applied, and also you don't have to take complete 2/3. Here, no bend deduction, but you have to take 2/3. Okay. In this way, there may be another company which says that, like we did previously, you don't have to apply bend deduction, and you don't have to take that complete 2/3 depth. Accordingly, you can work out. Okay, based on the companies, that is what they follow, right? So I have seen people taking, but most of the construction practice, what they do is they apply 2/3, because this L, what, for example, let us say if this is my footing. Okay, I'll explain you here. Let us say if this is my footing. Okay, let us say if this is my footing, and whatever L you are putting, right, this top will be like this. It will come in this way. I'll go with only bottom reinforcement, no need of top. Okay, this is bottom. This much it will come. Okay, only up to this much length it is enough. Okay, because that itself is your development length. From here, if there is a column here, if this is your column, okay, so your development length starts from the outer face of the column. From here your development length starts. Okay, okay, got it. That is the concept what we apply. Now if the depth of the footing, is, let us say, 500 mm, usually let us say if it is 600 mm. Okay, 600 mm. So if I want to find this L, if I want to find this L, so what would be the formula? Usual formula what we use to apply? We say overall depth minus, from the top we'll take out the 50 mm depth cover, and from bottom minus 50 mm. So it will be 500 mm. So that means this particular L, whatever you have taken, no, it will be 500. So 500 means roughly it will come up to here. Your 500 may come up to somewhere here. 500 will come somewhere here. So usually practically it's not required. 500 means if it is 600, 500 will come somewhere here, right? So practically that much length is not required, because actually it's a wastage of steel also. So that is why few of the client, what they say, you take 2/3 of the depth. Whatever answer you are getting, no, here, this answer we got, no, you take 2/3 of that. That is why I made you people to take 2/3. That means 500 is correct. For this you apply 2/3. Okay, usually we say 67, 2/3 is 67%, right? 67% only will give the L. So if I do this, how much it will be roughly? So 500 into 0.67, 335, or 500 into, yeah, 2 divided by 3. Yeah, it will be 333 mm. Okay, so then practically what we do, we try to keep this 330. So if it is 330, then obviously if it is 330, then obviously this much will be, this part will be up, coming up to here. So this will be 333 mm. You're getting my point? And this also will be 333 mm. Got it? So this is usually what we follow. But there are few people who say, no problem, you don't have to take 2/3, you take completely. In that case, you do according to that. Now the question is, let us say there are two people. One person is, the person one is applying this 2/3 rule. I'll write this as 2/3 rule. And there is another person who is not applying 2/3 rule. Then who is correct? Who is correct? Because when you're applying 2/3 rule, when you're applying the 2/3 rule, let us say your cutting length of the bar is coming, let us say 14 meter. I'm taking random. Okay. And when you're not applying, obviously the length will increase. It will come to 17 meter. So obviously, if it is coming 14 meter, then let us say the steel, considering the unit weight of a steel and all, let us say I'm taking some random value. It will come 100 rupees. Okay, let us consider 100 rupees or $100. Let us consider $100. Okay, I'll write $100. Okay, rough value I'm taking just to make you understand. Now here, since it is 17 meter, obviously the rate will increase. Let us say this is 150 rupees, or let us say this is $150, right? So both there is variation in the price, then whom you are going to consider. So usually this thing has to be decided initially only. Before the start of the project, you have to decide whether you are taking it or not. Okay. Now on the site, this is, everything is on the paper. I can do anything on the paper. This is Excel sheet I can do. But when you do the real execution on the site, for example, let us say on the, in the paper, in the Excel sheet you are done, you have to take 2/3 of the depth. Okay. But on the site, if these people do completely, then what you should do in the billing, when you do the billing means this is just an estimate. When the actual work is over, for example, this work is over. Okay, let us say today you did 5 footings of similar sizes. Then you have to do the billing, no, how much cost has gone into that. When you do the billing, in that case, what we'll do, we'll see exactly what has happened on the site. Okay, that is how it is. So few people, what they do, few contractors and all, they say that we'll take complete depth. Few people, what, in order to save the money and all, what they do, they say we'll take complete height. That means this L, whatever we are putting, no, we'll take overall depth minus top cover and minus bottom cover. Let us say if your depth is 500 mm. Okay, let us say if your depth is 500 mm. So if applying that rule, 500 minus top cover 50 minus bottom cover 50, how much it will be? 400 mm. Okay. Okay. So practically this length also should be 400 mm. This L should be 400 mm on the side. Okay. But what few people do, what contractor do, they show 400 mm here, but when they do the real execution, they won't give 400. What they do, they say, what few people do, instead of that, they say 500 minus 50 minus 50 minus 50, and then they apply the 2/3. They apply the 2/3. Okay, into, you are getting my point, they apply 2/3 rule again. So how much it comes out to be? We found it to be 333 mm. So what they do, they are telling that in the paper they have shown that we'll take 400, but in real site execution they have taken only 333. That means roughly 67 mm of steel he has saved. This side 67, this side 67. I'm just speaking of one rebar. Imagine how many bars will come. Imagine how many footings will come. In that case, they can save a lot of money. So that is why whenever you're doing a billing and all, you have to go and check the site, what the contractor has done. Okay. There are people, those who show something here, they say we'll do according to this 400 only. But on the site, what has happened? These people have not given 400. They have taken 2/3 and given 333. Whatever amount he has saved, that is a profit for him. Getting my point? So that is why. So BBS completely depends on the site conditions. If you are following the same thing, follow the same thing on the site. If you're not following the 2/3, if you want to take the complete depth, top cover, minus cover, do that. And same thing has to be executed on the site. You have to keep the L similar to that. If you're not doing that, then you take a 2/3 rule. Whatever answer you get, same should be the L on the site. Okay, because finally, whatever you do on the site, that itself will be paid to the contractor. Okay, all your doubts are solved. Now you don't have any problem. You can go with that. So ask your, if you're working in any companies, ask your project manager or ask your site manager, like what we're supposed to do. So if the site manager says that no, we are following a 2/3 rule where the overall depth minus top cover, bottom cover, and 2/3 we do, you follow that and make sure the same has gone into the billing, because usually the billing engineer will take care of that. But you being a site engineer, you have to make sure because ultimately the building engineer will ask you, the site engineer, like what has been done on the site. Okay, so that is why you have to understand all this concept. So I have explained everything. Two-third rule, not applying the two-third rule, and even the same thing applies for the bend deduction also. Now few people say that we don't do bend deduction, and later when they come for the building and all, they apply the bend deduction. Okay, that is 90 degree, 90 degree minus 40 we are supposed to do. Few people don't do. If they don't do, you don't, they don't claim it in the building. If you do, you claim it in the building. Okay, getting my point? So that is what I wanted to tell. And I think with this class, all your doubts, whatever you have, is everything solved. So finally, whatever you follow on your site, you do that. Okay, now you may ask, sir, I'm running my own consultancy, or I don't have anyone to ask. Then what I do? So what I say is you apply the two-third rule, which is the right practice to be done, because that much L is actually not required. Okay, because if the footing is only 300 depth, it's okay. Imagine an isolated footing having a 600 depth. In that case, you're just giving 500 L. So 500 on left side, 500 on the right side is 1 meter. So roughly you're wasting a lot of steel. So the simple procedure, you apply the two-third rule. Bend deduction, you don't have to do that. And if you want to do, you do it. Simple. Apply the two-third rule and don't do the bend deduction. This is what I say. But if your company follows that, you follow according to the bend deduction rule and you apply the two-third rule. It's completely up to you. Got it? Great. So I hope you have enjoyed my lecture up to here, and I've given you a complete idea regarding this bend deduction part and all. And similarly, based on that, what has happened? Based on that, I have prepared the Excel sheet and I've explained you how it has to be done. Okay. Now, if you want to change anything, you can change here. Ultimately, answer also will change. For example, what I can change is let me change only one small thing. Okay, otherwise my Excel sheet will change completely. Here I'll just take it out. This bend deduction, I'll take it out here, and here also I'll take it out. And you see what is the variation which has happened here. So small variation, and final value also variation will happen. Okay, now okay, see, you see no much variation has happened. I'll show you one second. See it now, answer is how much? 966.236. Okay, it is 966.236 is the answer what I have. And if I don't apply the bend deduction, what will happen? I'll take it out, and this also I'll take it out. Yeah. So what has changed? Nothing has changed. Nothing much has changed. Hardly anything has changed. See, initially it was 966.236. Now it has changed to 681. Hardly how much mm? 0.4. 0.4 has changed. That's it. Okay. Not a big change has happened. Even if you put a cost also, nothing will change here. Getting my point? So based on the requirement, you can do that. Okay. Great. I did for one. You can do it for, you can prepare same Excel sheet. You just copy the same Excel sheet. Okay. Say more copy and create a same Excel sheet. And in that you don't do the bend deduction. In one you do the bend deduction. Okay. You can prepare two Excel sheets and you can compare the value. That also can be done. Just in case if you want to see how much variation will happen, you can do that. Okay. Great. So that's it. So I'll get it back. Yeah, fine. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So here I'll give you a lot of assignments, and also I'll be explaining a few of the complicated footings where you can take out the BBS. The method remains the same, but still, since I take a lot of assignments so that you don't find any problems in future, we'll try to take that. So all these drawings I've already given you. I hope you have downloaded that. And if you remember, we had taken the quantity estimation for this footing as an assignment. Now for the same footing, you see, this time the reinforcement is given. Okay, what is written here? Raft bar in bottom, that is reinforcement bar in bottom, 12 diameter at 155 center to center spacing, and bar in top, that is both ways. Okay, now here what has happened? See here, this is actually a kind of isolated footing. If you observe here, it's isolated footing only. Why? Because there's one column and there's one footing, so it's isolated footing. But here, like I told you, all the isolated footing will not have only the bottom reinforcement. There's every chance that may have your top reinforcement. So when this situation comes, usually when you have a industrial structures and all, that means you're putting a RCC substructure. Over that, a steel structure will come, like your column, the steel column, the purlins, the rafters and all. Due to the wind load and all, there may be uplift and all. Sometimes because of that reason, we give the top reinforcement also. And if you don't give the top reinforcement, that column may punch your this thing, that footing, and it may bulge in this way, this portion. That is why in order to take care of that, minimum reinforcement will be given in the top also. So that is why if you observe here clearly, see, the bottom reinforcement is given, which we usually give in isolated footing, and then the distribution bar. But similarly on the top also we have given. This is actually a case of a combined footing, but it is not combined footing because you have one footing and one column. But I explained the reason behind that. Okay, so that is the reason you see you get a reinforcement here. It's written in the bottom and they write both ways. Now they see they don't give a column. All the drawings you will not, it won't be like you think. Usually what is mentioned here both ways. It means shorter span and longer span. This is in bottom. Okay, this is for the bottom. Similar, this is for the top. Again, both way means top shorter and top longer. Both way means bottom shorter and bottom longer. Few people, instead of writing in this way, they would have made 4 columns. Like this is for the shorter bottom, shorter longer. Then again for the top shorter, top longer. This they would have done. But here this person has not given. Now you can do the BBS for this. Very simple. This BBS, whatever you are going to do, it's similar to the Excel sheet what I've taught you here. This one, the combined footing I've taught you, same thing. This is how your BBS should look. So your bottom shorter will come, bottom longer will come. Then again your top shorter will come and top longer will come. Okay, nothing will change. If you want, we can do that also. I'll just input these values and you'll get the answer. Okay, so let me do that quickly. Okay, so it's written. Okay, first you have to mention the size of your footing. So it is 2900 by 2900. Just input here. I'll input here 2900. Okay. Yeah. 2900. Done. This is also 2900. Okay. Finish. Okay. Then what is the depth of your footing? So depth of the footing is 500. So input here 500. Done. Finish. So accordingly, you see, you got this reinforcement. Okay. You got the this. Okay. Where did I put? Wait. It has gone to the top. No. It should come here, not there. Yeah, here it should come. This is that footing. Okay, how much it is? 2900. 2900 and 2900. Okay, and depth is 500. So depth is 500. This is done. So you got the answer here. Your cutting length 2900 minus left side 50, right side 50 will be minus 100. So 2900 minus 100 is 2800. You know that. Same by default, you got the answer. And this depth also we know 500 minus top cover minus bottom cover into 235. Do same thing I have done. You got it as 267. Got it? Fine. Now come to the reinforcement part. So reinforcement has written you're supposed to make use of 12 diameter bar. How many F1 footings are there? So number it's not mentioned. Will for our understanding, I'll take only 1 year for time being. Okay. And what is the reinforcement 12 diameter? So input 12 here, input 12 here, input 12 here. Okay, fine. And it is 155, 155. So it was earlier I had put 150. You make it as 155. Okay. And here also you make it as 155. Done. Where did I do? Along the bottom I did. I want top also. This is top reinforcement. Similarly, come here. Top also you change. So once you change here, automatically this part also will change. Only the thing is you have to change this part now. Okay. This is 12 diameter. No, make it 12. This is also 12. Why? You know the reason. Okay. 12, 12. And what is the spacing in the top reinforcement? See, it's top written in both ways, shorter and longer. It is 175. So I'm making 175 here. I'm making 175 here. Finish. Done. Okay. Accordingly, you don't have to do anything. You got the answer. Total 20 bar is required. Here 20 is required. And in the top, you require 18 and 18. Why the okay? Why this becomes 17 then? This is 18. Okay, round up. I think small mistake we have done because this should have come. Plus 10, plus 10. Then why it's not coming? 175, 12, 12, 175. So round up, round up. Okay, wait. Okay. So this is one problem. See, if you interlink, if you write 3000 and all, it will create a problem. So always try to interlink it shorter. No, I should take longer one. Now it should come correct. Yeah, 17. Okay, because manually I'd input 3000. No, so obviously Excel sheet will not work out. So always try to interlink that. This it has to be interlinked. Okay, great. Now it is 17, 17. And I think, yeah, here also there is a mistake. See, Here also 3000 manually I had written. You should not write. You're finding along shorter, no? So to take the longer span. Spacing you're finding, no? Yeah. And here also it should not be 3000. Okay. You're finding the shorter, longer, no? You have to take shorter. That is P. Now it will be. Now it is correct. Here also you have to take. Fine. Now here it is correct. Okay. Anyhow, let me make it clear. I have taken shorter span. If I'm taking shorter, I have to take the longer one. Okay. Longer I have taken, correct. And if I'm taking the longer, I have to take the shorter. So shorter will be, yeah, shorter will be C. Yeah, so correct. B and this is C. So, okay, fine, good. Done. Finish. Your answer is ready. Only the thing is what change you're supposed to do, no? This answer will come in 10 diameter, which is actually wrong because we're making use of 12 diameter, no? So in that case, what you do, you strike out the answer, you delete this, you delete this, you delete this, you delete this. Why? Because it is 12 diameter, so your answer should come in 12 diameter. So what you do, you just come here, say plus this total cutting length, you multiply this total cutting length with weight of 12 diameter, which is 0.888, and hit the enter button. Finish. So if 58.35 kg of steel is required, similarly here also you are supposed to do same thing, 65, multiply this by 0.88. Okay, fine. Similarly here also, plus, click on this and multiply by, again it's a 12 diameter, so 12 diameter is 0.888, enter. Similarly here also, this one multiply by this one, enter. Got it? So this is the right answer what you have got. Got it? So if you want, you do it manually and check the answer what you have got. You'll get the same answer. So that is the easiness of doing a Excel sheet. If you prepare Excel sheet in this way, you can take out all the quantities. Yeah. So one I've explained. Similarly, rest you try to do on your own, because now you are in such a position where you can do all these things. Okay. Similarly, try to do it. I always tell, if you're working for the first time, do it manually. Then do it on the Excel sheet and try to verify the answers. Only then you'll have a confidence in that. Okay. Now try to do for the other thing also. All these things you try to do on your own. Okay. One assignment is done. I'll go to one more assignment now. So one more assignment is this one. Okay. Say I won't be sharing this drawing since these drawings are not to be shared. Okay, they're confidential drawing. Only whichever is shareable, I'm going to share. Okay, don't ask for all this drawing. Only thing is what you do, you just take a screenshot of this. If you are interested, take a screenshot. Now here, all the footings are given. Here you just concentrate on the reinforcement details. Again, same thing. Here S1 and S2 is mentioned. S3 and S4 is mentioned. What do you mean by this? The meaning is very simple. This you consider as a shorter span. This you consider as a longer span along the bottom. Again, top reinforcement. Again, this you consider along the shorter span, and this you consider along the longer span. Okay, if not in that way, usually what you can do is you can check the cross section of the footing. See, this is a cross section what is given. Now if you observe here, see where it is mentioned. So your S1 is S1 and this is S2 they have written, and this is S3 and this is S4 they have written. Okay, so how do you understand this? So it's a cross section what they have given. So you can consider your S1 to be your distribution bar and S2 be your main bar. Similarly on the top, this S4 is your distribution bar and S3 is your main bar. Okay, yeah, sorry, S4 is your main bar, because see, bottom shorter span, bottom longer will come. Again in top, shorter span, and inside that will be your the distribution bar. The main reinforcement will be at the top, but whereas in the bottom, the main reinforcement will be in the bottom. In the top, your main reinforcement will be the top. After the top, the bottom next to the top, this is top main bar. This will be below that, but in bottom this will be main. Over that the distribution will come, and in the top this will be main. Below that the distribution will come. Okay, so in the top this will be my main reinforcement, and this will be my distribution. In bottom this will be my main reinforcement. The dotted is a distribution. Okay, fine. And for that they have given it here. If you don't understand from there, they have given it here also. So how they have given, you can go through this drawing. So yeah, so this is typical. They have written like this is S1. Where is S1? This is S1. Okay, this is S2. Okay, and this is why it is dotted. The dotted indicates it's a top reinforcement, and S4 is top. S1 is bottom. Okay, you're getting my point. Okay, usually if you don't understand, whenever a drawing they mention dotted, it means it is in the top reinforcement. They mention it as, they put it in dotted line. Okay, that is a typical way of doing a structural detailing. Okay, so this is S1 and S2, and then based on that you can you can check this thing. Come to the footing reinforcement. Anyhow, it doesn't matter to you. You just take out the quantities if you are interested to take. Okay, so you take this as shorter span, you take this as longer span, and then you top, you take this as a shorter, you take this as a longer. Okay, very simple. And anyhow it's very simple also. See, this is 125 125, it is 150 150, right? Again it is 175 175, this is 150 150, 175 175, 150 150. Okay, 125 125, 125 125. Got it? Just in case you take a screenshot of this, try to do the BBS for this. If you have any doubt, get back to me, I'll solve your doubt. Okay, again, even though this is a isolated footing, this CF means combined footing, even though it's isolated footing, again you get a bottom reinforcement and top reinforcement, because it's an industrial structure. In industrial structure you get such kind of reinforcement. Okay, 2 assignments are done. Next we'll go to the third assignment. Okay, see, it's totally up to you whether you want to do it or not. If you are okay with the concepts, you don't have to do that. That's it, simple. Again here also same thing, footing schedule is given. Bottom rebar in L direction, that means along the length direction, and bottom rebar in B direction, along the breadth direction. That means this is your shorter span, this is your longer span. Okay, that is why we have prepared the Excel sheet in that way, bottom and top, and along shorter span, along longer span. Okay, got it, no? Then the drawing is given to you. Based on that you can take out the quantities. So this is a drawing given. Can you take out the quantities of here? Again here you see same thing, bottom shorter longer, and top also shorter longer, but it is given in both directions. It's understood. That means longer and shorter both are 12 die at 180 180. Okay, great. So you can do the quantity estimate, I mean BBS for this particular footing also. Try to do a 1 or 2 footing so that you get an idea. Okay, fine. Next, in the same way, I'm taking a lot of drawings. You take a screenshot of this, because all this, because these drawings are already shared with you. This drawing is shared with you. This drawing is also shared with you. This drawing I cannot share. You can take a screenshot of this. Okay, don't ask me for this drawing because those I cannot share. Even this also I won't share, but you can take a this thing, what is that, screenshot of this. You note down and you can do the calculation. Then if you want me to verify, you send me this Excel sheet and I'll verify it. Okay, yeah, bottom bar, top bar, again same thing. So bottom main, this is TRNS. This is, what is TRNS? Okay, I don't know what do you mean by TRNS, but actually it's a distribution steel, main bar and distribution, main bar and distribution. Okay, it's understood. You can do for this also. Okay, then after that, yeah, I had taken one drawing where I'd explained you this thing, which is that slope footing. For the slope footing, if it's a slope footing, also same thing, BBS won't change. Only in the estimation it will change, whereas BBS remains the same for the slope footing also. So for the slope footing, they have mentioned it here. You can do this, no? See, footing F1 and F2 is given. Forget about all these things. This is not required. In when you come to the BBS, this part is not required. Okay, only we are concerned with the steel. So it's written here, B1 at CNC, B2 at CNC. That means this is along the shorter span, this is along the longer span. In the shorter span, you're supposed to use 12 diameter at 150 center to center spacing. Along the longer span, also you're supposed to use 12 diameter at 150 center to center spacing. For F1 footing, how many numbers are there? 16. F2, there is 8 number. You're supposed to use 16 diameter at 150 in the shorter span, and you're supposed to use 16 diameter at 150 in the longer span. Pretty simple. If you want, I can do this for you. I'll go to the Excel sheet and let me take one footing. I'll take this particular footing. I'll go here. Okay, I'll do it here. Fine. Quickly tell me what is given there. Yeah. So I can do it in this way. So I'll do it in this way. Okay, I want the size of the footing, which is 2300 by 2300. So let me input that 2300. Okay, 2300, and this is also 2300. Okay, done. Then yeah, so this is done. Next I want this thing. So it's a what is the depth of the footing? Okay, so in the depth, what you're supposed to do, the depth of your footing, it will be your overall depth. Oh yeah, overall depth. This depth, you're not the overall depth. You're supposed to take this depth in case of this footing. Yeah, this you may have a doubt. Yeah, see, when you're doing this slope footing BBS, your D will be only up to this depth, okay? Because your L will go only up to here, okay? So you have to consider the D2 one, not the D1. D1 is overall depth, that is not required. Your L shape will be bent only up to here. So take D2 dimension, okay? So for the D2 dimension, we'll go back to that again. So D2 we'll find from here. So we have to take D2, which is 200 and 200, both the case. So again, it is 200 for us. So I'll take 200. So depth will be 200. Okay. I'll change according to that. So this we can round up. We can make it as, yeah. So you round it up since it is coming in this point, round up and comma 0, close the bracket. Okay. So error is because of the bracket. So give one open bracket. Now it will be okay. Fine. 67, 67. Got it? No, you know, when it comes in decimal, try to change it. Yeah. Finish. Now come to number of bar. How many F1 footing are there? There are 16 F1 footings. So come here, make 16 here number and make 16 here. Finish. Again, then diameter. You're supposed to make use of a 12 diameter at 150. Okay. So this is along the shorter I'm doing. First this one, 12. Okay. And spacing is 150. All right. Spacing is 150. And see, this is shorter span. Okay. So shorter I've done 12 at 150. Next I'm doing for longer. So longer I haven't changed. So in the longer it is mentioned again 12 at 150. So here you change it to 12. Yeah. You make it 12 and this is 150. Got it? Done. Finish. Once you do all this update, finish. Your answer is ready. Your answer is ready. What is answer? Simple. Your total cutting length will be 2200 plus 67 plus 67. Okay, I haven't done the bend deduction. If you want, you know the concept now. Bend deduction, if you want, you apply it. If you want, let me apply minus 4 into, which is that? This one, 12 I'm supposed to take. Okay, done. Here also, if you want to apply bend deduction, minus 4 into 12. Done. Okay, fine. And total cutting length will be how much? How much cutting length? 2.286 is the cutting length of one bar, multiply by number of bar. Number of bars I'm getting 16 into 16 I have to do because there's 16 F1 footing. Okay, got it? So totally it will be how much? 3. Now one change should happen. Always remember, because I'm finding a weight of a 12 diameter bar, but my weight is coming in 10 diameter column. So this I should delete. Okay. So when you do this, this is one problem. You come in the 12 section, right? Plus this multiply by 12 value. Enter. Finish. Your answer is ready. Plus this one multiply by 12 value. Done. Finish. So this is a total steel that is required. If you're putting a F1 footing of 1200 by 1200 by 400, having 16 numbers according to this particular drawing, okay, according to this particular drawing, then your BBS will be this much. Okay, when you give it to the bar bender, you have to tell cut this 2200, cut this 67, make this 67, 67, 67, 2200, and accordingly you try to do. Okay, and if you ask what should be the, if you ask what should be my total cutting length, you should tell you should cut your 2.286 mm of a bar. Out of that, 2200 will be your straight. This will be 67. This will be 67. And then the bend deduction is going to apply. So totally it should come out to this. Getting my point? So in this way, you're supposed to do the bar bending schedule. Okay, great. I think most of the things I've taken care of. Okay. And then again, I think it's enough. Most of the things I've explained you. Again it's the same thing. If you want, again not required. This is another again I won't share this drawing. Again, this is another industrial building, because whenever you find, no, this is actually isolated footing, F1, F2, F3, F4. If it is combined, it will be CF1, CF2. It's isolated, but you're getting a bottom reinforcement shorter span, longer, top reinforcement shorter, top reinforcement longer. Done. If you want, you can do BBS for this also, so that you don't have any doubt. Now let me go to few of the industrial projects. Again, same thing. This was one of the projects which I had explained you in the quantity estimation time, right? Now, see, this is BBS. If you can do, very simple. We can do the BBS. Same thing. Just I'm showing you just for your understanding. Okay. Yeah. Again, same. Bottom face, shorter side, longer side, 16 at 150, 16 at 150. Again, top face, shorter side and longer side. You can do the BBS, very simple. What you're supposed to do, just take that value and you have to input that in the this particular area, this particular thing. Okay, because you have a bottom, you have a top reinforcement. So this you can do, no? You can take a screenshot of this And if you want, you can solve 1 or 2 problems, so that I'm trying to, touch all the drawings. This is another industrial project, okay? Because industrial projects are a little bit complicated. That's it. This is one more. I think, yeah. This is another commercial building, a very big commercial building. I won't share this drawing, okay? Because few things I have shared, I already told you. And then don't message me for the drawing. Those drawings which are shareable, I'm going to do, because all these things is not required for you. Whatever is required, I'm showing it here. Okay, you can take a screenshot of this. Yeah, you can take a screenshot of this and you can take out the quantity. Okay, again, see here. Yeah, see here. F1, F2, F3, F4. This is your isolated footing. F5 is also your isolated footing. F8, F9 is also isolated footing. Okay, and here what has happened, I'll tell you. See, this much footing. F1 up to F3 footing. This is your isolated footing where you have reinforcement in the shorter span, that is bottom reinforcement and long reinforcement you can do. There is no top reinforcement here. F1, F2, F3 same. Similarly, your F8 and F9. F8 and F9, this is also isolated footing where you have a shorter reinforcement in the bottom 12 at 100 and 12 at 100 in the longer span. These things you can do. Whereas this F4 footing you see, whereas this F4 footing and your F5 footing, this is not your, this is also isolated footing, but these people have bottom and top reinforcement. Now you see how these people have mentioned it here. F4, they have given reinforcement 20 die at 125 center to center spacing. This is bottom in the shorter span, 20 at 125 center to center bottom in the longer span. Now he has mentioned top reinforcement. So in the top, you are supposed to provide another 12 die at 150 in the top along the shorter span, and 12 at 150 in the longer span. You can do that, no? Very simple. You have an Excel sheet ready, or you do it manually, you get the answer. Similarly, F5 also same thing. 20 at 125 along the shorter in the bottom, 20 at 125 along the longer in the bottom. Now for the top, they have mentioned it here. 12 at 100 center to center spacing in the shorter span, and 12 at 100 center to center in the top. Okay, pretty simple. Done. These things also you can do. Now I'll go with another footing. This is also another industrial building. Now similar. You know, F8, F9, F10, everything is given. Bottom shorter, bottom longer, top shorter, top longer. You can do it. And I'll go to one of the commercial building. Yeah, this is another commercial building. Okay. So I've taken care of all the buildings, commercial, industrial, house building, everything I've explained you. So this is commercial building. Here what has happened? This F1 footing, this F1 footing, F2, F3, F4, all these are your isolated footing. How did I say that this is isolated footing? Very simple. Forget about everything. Come to the reinforcement part. Okay. We should always concentrate on the reinforcement part. So this is your reinforcement part. Concentrate here. Enough. So what is written? Bottom and top is written. Fine. So only the bottom is showing, that is 12 diameter at 150 center to center spacing. Okay. This is also 12 at 125 center to center spacing, 12 at 100 center to center spacing, 12 at 100 center to center spacing. He has written only bottom, but he has not mentioned whether it is shorter or longer. If they are not mentioned whether shorter or longer, it means both ways, shorter and longer, you have to provide 150, 12 at 150 along the shorter, along the longer. In case of F1, F2, F3 and F4. Got it? Because there is nothing mentioned in the top. Now when you come to the combined footing, CF1, CF2, CF3, 4, 5 means it's a combined footing. C for the combined, F for footing. So here you will get bottom reinforcement and top reinforcement. So in the bottom, you're supposed to provide a 16 die at 150 center to center along the shorter, along the longer. And in the top is mentioned 16 die at 150 center to center along the shorter and along the longer. Got it? In this way, CF1, CF2, CF3, CF4 and CF5 you're supposed to do. Got it? So in this way, you can take a screenshot of this. If you're interested, you take out the quantities of this. Okay, very simple. If there is bottom and top mesh, use this Excel sheet, the last one, this will solve your answer. If there is only bottom reinforcement, then use any one of the Excel from here. Your answer will be ready. And make sure, because here whenever you get the answer, still answer, make sure to change it. Suppose if it is 12 diameter, it should come in 12 column. Okay. Later, I'll explain you one more way, not now. Maybe once I finish all the lectures, I'll take you to a few of the advanced topics of the Excel where you don't have to change this. Right now, you change it, but later I'll tell you one method where you need to apply the coding, if formula, if while and all. There you don't have to change. The moment you insert 16, automatically your answer will come in 16. The moment you enter 20, your automatically answer will come in 20 dia column. 20, 20 column. I mean, this particular row. Right now, you will not do that. Right now, you practice this method. Later, once I finish all the BBS part, when I go with the Excel calculations, I'll add one lecture where you can make use of that formula, because you need to write here. Okay, if and all you need to write, we'll do that later, so that you don't have to change. So that comes under the advanced part. Right now, you finish these things. Yeah. So I hope I was able to explain most of the things, and I've covered almost all the drawings here. Okay, industrial, residential, commercial, and all. So everywhere I taught you how it has to be done. The concept remains the same. Only the size of the footing will change, and only the diameter and the spacing is going to change. The rest, the method remains the same. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, we will see how to find the BBS for the RAF foundation. Okay. So again, a RAF foundation is again very simple. You just need to understand the concept. That's it. Okay. So I think I have a drawing here, and for this particular drawing, I'll show you how the BBS has to be done. So what I'll do, I'll just select this particular drawing. Okay. And let me say Control C and Control V, and just I'll paste only the raft portion here. Okay. So this is where the BBS will come. Okay. Getting my point? So very simple. You just understand the concept. Raft foundation and combined footing both remains the same. Okay. The difference will come in the size of the footing. Okay. For the combined footing, what we used to do, we used to have a bottom mesh, and over that your distribution still used to come. Similarly, you had a top mesh, and beneath that and below that your distribution still used to come. In the raft foundation also same thing is going to happen. Okay. There won't be any difference. Okay. Only the thing is, what will happen in combined footing, there won't be lapping. What I'm trying to tell, for example, if I'm taking this as my combined footing, okay, if this is my combined footing, let us say the size of the combined footing is, let us say, I'll take this as 5500 mm, the length, and the breadth I'll consider to be 3000 mm. So here we used to do the simple method, isn't it? How we used to do the cutting length, this L we are supposed to find, bar will go straight in this way, and this, you know how it has to be done, isn't it? Both the side you deduct the cover, this L, you know, this length, you can do. And since 5.5 meter is less than 12 meter, so one straight bar is enough. You don't have to do a lapping and all. But in the raft foundation, what will happen? The only problem in the raft foundation is that the size of the foundation is not small. For example, if I measure this dimension, let me measure this dimension, okay, from here to here. Okay. So what I'll do is I'll increase the size of this. Go to the properties. Okay. PR, enter. And from here, I'll increase the text size. Okay. So arrow is our text. So text height is, let me go for 150. Okay. Text height. It's not visible still. I'll go with 500. Yeah. So it should be visible. Okay. Fine. Let me still do that. Give me a minute. Yeah. So it's not happening, not an issue. You see this dimension, okay? So this length I measured, and you can see how much it's coming. It's coming 34,590 mm. If I divide it by 1000, it comes out to be 34 meter. So this length is 34 meter. Now try to understand. So this length is 34 meter, but the bar what is available is a 12 meter bar. Now what will happen beyond 12 meter? Exactly. You're supposed to do the lapping. So only in the cutting length, your lap length will increase. Other than that, nothing is going to change. This much you understood. So that is why I wanted to tell you that in the raft footing, what will happen, and raft foundation, what will happen, your lap length will be added. That's it. Okay, very simple. So how we are going to place the bar? It's very simple. You just start your bar in this way. Okay, your first bar will be placed in this way. Okay, and again next bar will be placed in this way. Only up to this distance you place it. It will be placed in this way. Finish. Only 3 bars you place here. Similarly, you place 3 bars in this way. Okay. Again, you place 3 bars in this way. Fine. So only this number of bar. I'm just showing 3 number. That may depend. Depends on the this particular length. You divide by the spacing, you get number of bar. Cutting length is very simple. Okay. This will be my cutting length. Okay. After that, next time when you place the bar, this bar will be starting from here. It will go like this. Okay. Got an idea how the bars will be placed in the raft foundation? So now you'll find the cutting line for this magenta color line, whereas previously for the yellow line, we are supposed to find. Then again, your bar will go in this way. Again, your bar will go in this way. Okay, I hope you're able to understand. Your bar will go in this way. Your bar will go in this way. Okay, fine. So once this is done, you start with the distribution steel again. The distribution steel again, here it will be like this. It will come like this. Okay, here it will come. Maybe you'll get some 10 or 12 bar. Similarly, you do here also. Okay, similarly, you do here also. Fine, fine. After that, next what will happen? You take it completely. Now you got an idea. In the center, it will go completely. So in the raft foundation, now here the problem is my footing is not in regular shape. It is having some offset. No, that is the reason I'm doing in this way. But I'll teach you the concept, not an issue. Okay, you understood how it has to be done. This the way you put the raft foundation, you understood. No, only bottom I did. Similarly, you'll do in the top also. Like combined fitting we used to do. No, whatever was my bottom, the same will be my top. You just have to multiply by 2. You'll get the answer. That is understood. Now, what I'll do? So what I'm going to do is, see, this length we had 35 meter, isn't it? So leave it. I'll take another box and let me do that. Okay. So let us say this is a footing what I have. This is my combined footing. Okay. I'll go in this way. And what is the dimension? So for dimension, I'll go with a different this thing. Wait. Uh, yeah. Fine. Let me draw one rectangle here and I'll do the rough footing here. Okay. And let me check the dimension. Okay. I think this should be simple. Yeah. Okay. Now you try to understand. So how much it is? It is 9,452. Okay. This will not work out. No. I'll have to take a bigger one. Let me go with a bigger raft. Okay. Imagine this is a raft footing what I have. This much big is my raft. Okay. And I'll measure this distance now. What I'm trying to do, I want it more than 12 meter. That's it. Yeah. Now it is okay. See, this is 21,887 mm. So that means it comes out to be 21 meter. Okay. Now try to understand. This is 21 meter. If you want, I'll write here. This is 21 meter. Okay. Fine. Now, first let me go with, this is the first bar, shorter span bar. We are going to place first. Imagine that you are putting a bar in this direction first. Once it is done, it's very simple. Now, we'll start to find the cutting length. How we are going to put the bar here? Of course, you'll start the bar in this way. I agree with that. You'll take it straight and then you are going to place it here. This is how you put. But the problem is this is 21 meter. The bar that is available in the market is 12 meter. So what you have to do? Exactly, you have to do the lapping. So how many times lapping will come? That is important. So what we'll do? We'll take 21 and we'll divide it by 12. So what is the answer you're getting? You should get some 1 point. 21 divided by 12. You'll get 1.75. So forget about the decimal point. After this 75 you forget, only one, only this number I need to count. Okay, whenever you find the number of lapping, I always told you forget the digit after the decimal point, only the before that is only one. No, so only one lapping will come. So what we will do, we'll bring our bar in this way. Okay, and maybe it will stop somewhere here. Okay, and then I'll bring one more bar. I'll come here, this lapping will be done. I'll lap it in this way. I'll take my bar in this way and then L will be given. That's it. So this is how the lapping, this is how the BBS for the footing will be done, for the raft foundation will be done. Now, can you find the cutting length of this? I'll find it for you. It's very simple. 21 meter, I'll write 21,000. Okay. Minus, from the left side, I'll take, since it's a raft foundation, it will be 50 mm cover on both the side. Minus 50 from the left side, minus 50 from the right side. Okay. Fine. So what is the answer you're going to get? So 21,000 minus 50 minus 50. So this will be 20,900. Okay. So this will be 20,900. This complete length from here to here. This one from here to here. This will be how much? 20,900. But since there is one lap, we have done one lap. No, you just add the lap length. This lap length you are supposed to add. So what you will do? 20,900 plus lap length. How much you'll take? Let us say in the drawing it is mentioned 50 times the diameter of the bar. So I'll take 50 and let us consider I'm using a 16 diameter bar. So multiply this by 16. Tell me what is the answer you are going to get? Plus 50 into 16. Fine. So 21,700 mm. Fine. But this is only the straight portion. What about the L portion? This L portion, to identify the L portion, you should know what is the depth of your foundation. For raft, let us consider the depth of my raft foundation is 1,500 mm. The raft and all won't be like 400 mm, 500 mm. It will be at least more than 750, 1,000, 1,500 mm. I'll consider the depth of my raft foundation is 1,500. So can you find the L? It's very simple. 1,500 minus top 50 mm cover minus bottom 50 mm cover. And now, if you want to multiply this by 2/3, you can do that. Else, usually for the raft, this L will be very big. This L will be usually big. So what we'll do, we'll go with the same answer. Or what we can do is we'll take 2/3 of this. This is a usual construction practice what we do. We don't keep the complete L. But again, it depends how it is given in your drawing. But here for our understanding, I'll take 2/3. Okay. Which we usually did for the isolated footing and all. So there is no, difficulties in that. Into 0.67 I'll do. So 938 mm. Fine. Finish. You got this L. So if you want, I'll write. This is 938 mm. 938 mm. This L, okay. And this is also 938 mm. Both the side it will be same since I'm taking 2/3 of that. Now you find the cutting length. Now it's very simple to find the cutting length. So the cutting length will be how much now? So add everything. 21,700. This is span plus 938 on the left side plus 938 on the right side. So this will be a total cutting length. Okay. 21,700 plus 938 plus 938. 21,700 plus 938 plus 938. This is 23,576. Finish. Your BBS is ready. BBS in the sense your cutting length is ready. So once you know the cutting length, you can find the number of bar. How you will find the number of bar? To find the number of bar, you should know the opposite length. This length you should know from here to here. I'll consider this length to be, let us say, 7,500. I'm considering a figure because usually in the raft foundation, this is what happens. 7,500, let us consider. So what we'll do, we'll find the number of bar. 7,500 minus 50 will do. On both the side cover you're supposed to take out. So it will be 7,400. And let us consider using a 16 diameter bar. Okay. And at, let us say, you're placing it as 150 center to center spacing. Or 150 will be too much. We'll keep at 200. 200 center to center. So what you'll do? 7,400 divided by 200. You're getting my point, no? It's very simple. We're not doing anything which has not been taught to you. Everything is taught to you. Only the thing is cut in BBS of the footing of the raft foundation. Only the lap length is the additional thing which you need to understand. Okay, fine. So 7,400 divided by 200 if I do, I'll get 37 number of bar. 37, since it's a number of bar plus 1, it will be 38 number of bar. Finish. 38 numbers. That's it. Your BBS is ready. You know all the thing. You know the total cutting length. You know the number of bar. You know the weight of a 16 diameter bar. Multiply all the three quantities. You'll get the weight of the steel. Simple. Very good. So this is how the BBS for the raft foundation has to be done. Okay. I hope that you are able to understand the concept. Okay. Fine. So now let us consider. I'll delete other things. Now let us consider. Okay. Yeah. Now let me consider this portion is done. No. Now, this is, I told that this is just 7,500. So if it is 7,500, there is no point in lapping because it is less than 12 meters. You just place a bar in this way, take your bar. This will be a shorter side span. I mean, shorter side bar. Okay, here there won't be any lapping. Now for us, now let us consider just in case this particular length. Okay. Now let us consider this particular length what you had. It is, let us say 15 meter. I'll write 15 meter. So in that case, you're supposed to do the lapping. So again, what you'll do, you'll bring a bar like this. You'll take it up to here. So maybe your 12-meter bar will end up to here. Then you'll bring another bar. Okay. You'll bring another bar like this. You'll lap it. You'll bring another bar. You'll lap it like this and you'll take it like this. You'll take it like this and it will be bent in this way. So how you'll find the cutting length? Again, cutting length is simple. Just 15 meter minus 50 you do. You'll get the cutting length, the straight portion, plus whatever lap you have. It is 50 times the diameter of the bar we have considered. So this lap length, you just add it. That's it. Finish. So again, you know this. So again, this L you have to calculate. So L, it remains the same because 1,500 is for overall depth. Okay, it will be again 938, 938. and then add everything, you'll get the cutting length. And then if you want to find the number of bar, so this is 21 meter, no? So 21 minus 50 you do, you'll get how much? 20,900. How much you'll get? 21 meter. So 21 meter, 21,000 minus 50. You'll get 20,900. Okay, we'll do that only. 20,900. We'll divide it by the spacing. Let us consider spacing is again 200 mm. You divide it by 200. So you'll get 104.5. So you'll take 105 plus 1. So 106 number of bar is required in this direction. So you'll be providing 106 number of bar in this direction. And then it's, let us say it's a 16 diameter bar only. Multiply by the unit weight of that, you'll find the BBS. Got it, no? So this is the only thing, only the difference which will come in the raft foundation. Rest all things are very simple. Only the thing is lap portion you need to understand. But again, there's one more catch in this. What is the catch? I'll tell you. Okay. So the catch is, let me remove this thing. Remove this thing. These things are not required. Okay. I'll take out this portion also. And I'll take out this portion. And I think, yeah, this portion also I'll take out, not required. Now, every time, now whatever we understood is from the quantity estimation or from the BBS point of view. But practically on the site, you'll not do like this. Now, you know that every time a lap is coming. So again, the next bar which you are going to provide, you'll not place it like this again. You'll bring the L-shaped bar. You'll bring it here. Okay. Then again, you'll give a lap. Then you give this thing. And you won't take it like this. Why? We know one thing. Whenever you do the execution, we need to understand not more than 50% of the bar has to be lapped at one section. What do you mean by that? If I have 10 bar and in all the 10 bar, the lapping is coming. Here, how many bars you had? How much bar we got? I think 35 bar something we got. So out of 35 bar, not more than 50% means out of, let us say 36 number of bar you're supposed to provide. Okay. So what is half of 36? 18. So not more than 18 number of bar has to be lapped at the same position. So if you lap all the bar in the same position, that means this particular point will be a weak point. Got it? You're getting my point? So the code says that not more than 50% of the bar has to be lapped at one particular section. So what we'll do, the next bar will not put like this. Next bar, what I'll do, I'll change it. Change in the sense, I'll start to put the bar from here. And I'll take a straight 12 meter bar, which may end somewhere here. Fine. The moment the 12 meter bar ends here, I'll bring one more bar. Then I'll do the lapping. There won't be any change in the lapping. But now you see, did the lapping happen here? First lapping happened here, no? But the second lapping happened here. So in this alternatively, I'm going to do out of 36 bar, 18 bar I'll lap at this position. So next bar again, what will happen? This is my next bar, okay? I'll stop it here. Then from here, the lapping will happen. So again, you see, 50%, no? Finish. After that, next bar again, I'll bring from here. I'll take it up to here. I'll lap it here. Fine. Now you are able to understand the concept. After that, next bar again, I'll take it up to here. I'll give a lap. I'll bring it like this. Finish. I'll take up to here. After that, next bar again, I'll bring from here. I'll take up to here. Then I'll give a lap. Okay, now you tell me whether 100% of the lapping has been done. No. Why? If how many bars are there? 1, 2, 3, 4, 5, 6 bar. Out of 6 bar, what is 50% of 6 bar? 3 bar, no? So only 3 bar I have done the lapping here. Only 3 bar lapping. See, one lapping at this junction, second lapping at this junction, third lapping at this junction. So out of 6 bar, only 50% of the bar has been lapped here. Remaining 50% I have lapped at this junction, and this junction. You're getting my point? No, this should be equal. I mean, if it should not come parallel, all 6 bars should not be lapped here. Alternatively, this will lap here, next bar lap here. After that, here in this way. So that is what you need to understand. But cutting length remains the same. This point is from execution point of view. In the execution, when you find the cutting length, what you need to do? You need to chain the bar. That's it. Whatever bar this cutting you kept, no, this you have to turn and start from here. Getting my point? This bar, if you want, I'll take out everything. I think I should take out everything. Yeah. So in the site, what you'll do, this bar first you'll put like this one straight bar, and this lapping you'll do and putting it here. Next bar, this straight bar, you'll start from here. In this direction, you'll put. So it will stop here, and this bar you'll bring in this way and you'll put it here. Getting my point? No, that you need to do on the site. Simple. Okay. Yeah. So I hope you were able to understand the concept about the raft foundation. So there is no much complications in the raft foundation BBS. Only the thing is about the lapping portion you need to understand, and only lapping portion you need to understand. While doing the execution, you need to understand about the alternate lapping. One lapping if you do here, second should come somewhere there, which where when you do the execution, the site engineer will should take care of that. As a quantity estimator, you just have to find the cutting length, which is same for all the bar. Okay, simple, no? Yeah. So I think I've explained you this concept of the raft foundation. In spite of this, if you still have any doubt, you're not able to understand, you can always get back to me. Okay. Yeah, that's it. So other than that, there is no doubt left out in this. I've explained you how the BBS for the raft has to be done. Concept remains the same. Only the thing is additional lap length you have to add. Now let me give you one more case. The case is that let us consider I have one more footing. This is one more footing. Okay. And let us say if this is let us say 50 meter. 50 meter. So now what will happen? Again, same bar will go same only. But how many lapping will come? Because 50 meter is a span of your footing and one bar is 12 meters. So how many lap will come? So number of lap will be, that is important. Number of lap. So that will be 50 divided by 12. Okay. Tell me how much will come. So 50 divided by 12, 4.1. So 4.16, which we consider it to be 4 number. We have to just take the number before the decimal point. So 4 is the first number. So 4 numbers, finish. So 4 times you'll do the lapping. So practically what you'll do, simple. You'll start your bar from here. This is your first bar coming. First bar coming. It will stop somewhere here. Then you'll bring your next bar. Bring your next bar. You'll lap it here. It will take here. Somewhere here. Then again your 12-meter bar will end here. We'll lap here. Bring here. So 2 lapping are done. Next again your bar will end here. It'll come here. You'll fine. Next year another lapping will come. This will be a last lapping. And then it will go straight. Understood? How much lapping was there? 4. So practically how much lapping you are given? 4 only you are given, no? So 1 lap, 2 lap, 3 lap, 4 lap. Can you find the cutting length of this? Very simple. How you will find? This is 50 meter. Okay. 50 meter is 50,000. Minus 50 from the left side, minus 50 from the right side. Okay. You do that. So how much you'll get? It should be 49,900 something, no? Yeah. 50,000 divided by 50 minus 50 minus 50. So it is 49,900. Okay. Fine. Now 4 times lap you're supposed to add. So 49,900 straight portion. Okay. Plus how many lap? 4 times. So 4 into 50. Let us say each lap is 50 times the diameter of the bar. 50 into, let us say I'm using a 16 diameter bar. Okay. Plus this L I want, no? This L I want. This L I know. I'm taking some random value. Let us consider the L what I got is 750. I'm taking random, okay? Just for our understanding. Else you know how it has to be done. Whatever is the depth of your footing, top cover minus cover, and multiply that by 2/3, you'll get that L portion. So this is 750. This is also 750. Okay, fine. That you add in the calculation. So plus 750 plus 750. Yeah. What will be the answer? 49,900 plus 4 into 50 into 16 plus 750 plus 750. So this will be 54,600 mm, or let us say 54.6 meter is my cutting length. So if somebody asks you, tell me the cutting length of this, finish. Your cutting length is ready. 54.6 meter is my 54.6 meter it is. Okay, is my cutting length. After that, rest things you know how it has to be done. To find the number of bar, this length divide by spacing. If you do, you get number of bar. Number of bar multiply by cutting length into number of into weight of 16 diameter bar will give you the total weight. Fine. Yeah. Now you tell me one thing. Next bar, how you'll place? Exactly. Next bar, when you place, you have to be careful on the side. So next bar, what we'll do? We'll start from here. So this may come somewhere here. Okay, fine. Then I'll give one lapping here. I'll take the bar. I'll stop here. My second lapping will be here. Then again, I'll bring a bar. We'll give a lap here. Okay, it will stop somewhere here. Okay. Then I'll bring one more bar. I'll give a lap here and it will go straight like this. Okay, only 3 happened. Okay, wait. This I have to be careful. This is okay. Next, I'll bring here. Yeah, I'll bring here. Next bar lapping, I'll give here. Come here. Next, it will be here. Yeah, and next it will be. Yeah, now it is all right. Yeah, yeah. So how many lapping happened? Again, 4 lapping I should get, but it has to be alternate. Exactly. One is here, second is here, third is here, fourth is here. So alternately it has happened. So again, next when you come, the same will come here. Getting my point? That's it. So I hope you enjoyed this lecture. We're able to understand how the raft BBS has to be done. Remaining the method, the way how it has to be put, everything remains the format and all. Now by this time you should have that knowledge how the format will be done. You'll be writing same thing like here we did for the combined footing. No, like you'll be having the bottom reinforcement, you'll be having the top reinforcement. Rest everything remains the same, but it will take some time for you to make the calculation for the raft portion. Okay, yeah. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you.